So I'm going to go over just a couple of problems from your practice examination number 3. So the first one right here is this limit problem, and you'll notice that if you put in a 3, you have a 0 on the top and a 0 on the bottom. So remember, whenever a limit is of the form 0 over 0, we can apply L'Hopital. Again, that's only because it's of the form 0 over 0. And when we apply L'Hopital, then we can take the derivative of the top, and so we would get 2 times the quantity 3 minus x to the first power times the derivative of that, which is just negative 1, all over the derivative of x minus 3 is simply 1. Remember, we're not taking the derivative of this entire thing. If we were, of course, we would need to apply the quotient rule. We are doing L'Hopital's rule. So you take the derivative of the top over the derivative of the bottom. We find the limit as x approaches 3 of 2 times the quantity 3 minus x times negative 1. So I'm going to put that there. And if we put a 3 inside, we would get a 0. So our answer is just C, 0. In this problem, units are really important in understanding how to do this problem. So I like to just think of a coordinate axis because it says for a car traveling at a speed of s miles per hour, that means that miles per hour would be on this axis here because it's c of s. So obviously s is here and c of s is here. S is in miles per hour. C of s is measured in gallons per mile. So this is in gallons per mile. This integral is obviously the area under the curve, right? So if I'm trying to find an area, just think of a rectangle, right? How would you find the area? You do width times height. So the units of this are going to be that same type of thing. They're going to be width, which is miles per hour, times the height, which is gallons per mile. And so the miles cancel out, and so our units are just gallons per hour. And so the correct answer choice is C. So again, by drawing the diagram there, I think you really make your life much easier. On this question here, it says the equation of the tangent line to the curve y equals blah, blah, blah at x equals negative 2 is this. So the equation, this right here, is the equation of the tangent line at x equals negative 2. What is the value of k? This is the equation of the tangent line. We would know that the slope of this, let's just look at that for a second, slope is 1. And so if this is the equation of its tangent line, then this slope must also be 1 at x equals negative 2. So let's see if we can figure that out. So y prime equals the derivative of the first, the top is k, times the derivative of the second minus, because it's a quotient rule, the first times the derivative of the second, and the derivative of that is just 1, all over the second squared. And so, of course, we're looking at this at a value of x equals negative 2. And so let's put that negative 2 in. We have k times k minus 2 minus k times x is negative 2k plus 8 all over k minus 2 squared. And so we simplify that to k squared minus 2k plus 2k minus 8 all over k minus 2 squared. So that simplifies to k squared minus 8 over k minus 2, the quantity squared. Now, again, the slope at negative 2 should be equal to the slope at negative 2. We just make that k squared minus 8 all over k minus 2 squared that we just found equal to 1. And so we have k squared minus 8 equals k minus 2, that quantity squared. I'm going to just square that out. K squared minus 4k plus 4 equals k squared minus 8. Let's scoot the k over here, so we have 4k. Obviously those k squares cancel out, and then put that 8 over there, so we have 12. In other words, k equals 3. So D is our answer there. In order to do number 15, you need to remember a formula that we have not gone over for a while, so I wanted to bring that up. The derivative of a to the x power is a to the x ln a, and you do need to memorize this, so please get that in your head right now. Once you know that, this is the baby, of course, so the derivative of 5 to the circle is 5 to the circle a to the x, ln a, so ln 5, times the derivative of the circle, which is 3x squared. So which of these is our answer? We have the 3x squared, ln 5, 5 to the x cubed minus 2, so B is our answer there. Now 16 is one that you need to recognize as an integral. Remember that the limit as n approaches infinity of this is going to be our width here, our delta x, and then this is our function, so obviously sine is our function. We're going from 0 to n over n, which is 1, because you see that 1 over n is our slices, so we're going pi n, 2 pi n, all the way to n pi over n. And then what are we doing? We have the 1 over n here, we have the 2 over n here until the n over n. So we're multiplying all those by the pi. So we have, instead of just sine x, we have sine of pi x. In order to evaluate this, we need to u sub. So u is this pi x. Our du is going to be pi dx. In other words, 1 over pi du is equal to dx. And so we have, instead of 0 to 1, our new bounds are going to be 0 to pi, so 0 to pi of sine u times 1 over pi du. Oh, I forgot to mention what happened to the 1 over n. Well, that was just our delta x, so that became our dx there. So anyway, take that 1 over pi out. The antiderivative of sine is negative cosine from 0 to pi. So we have 1 over pi. I'm going to just let that negative hang out there. Cosine of pi minus cosine of 0. What is the cosine of 0? That's just 1. And the cosine of pi is negative 1, because remember cosine is x stuff. So we have minus 1 minus the cosine of 0, which is 1. So minus 1 is minus 2. So minus 1 over pi times minus 2 is going to be 2 over pi. So our answer is B. Now let's go ahead and do this problem here. So it gives us this table of values with f and f prime values, and it says the line tangent to the graph of f of x and parallel to the segment between the endpoints. So if it's going to be parallel, that means same slope, so we better find the slope between the endpoints. So that is going to be f of 10 minus f of negative 2 all over 10 minus a negative 2. So we have 2 minus 26 all over 12. So that's negative 24 over 12, which is negative 2. So basically, in order to have tangent, we need the same slope. So where is the slope? Negative 2. Right here at the point 423, the slope is our negative 2. So they are parallel. So basically, now we just want to find the equation of that line. So the point is 423 and the slope is negative 2. So we have y minus y1 equals the slope times x minus x1. Y equals negative 2x. That's plus 8 plus 23 is plus 31. Where does it intersect the y-axis? Well, the y-intercept is 31, so that answer is C. At each point xy on a certain curve, the slope dy dx is 4xy. If the curve contains the point 0, 4, so 0, 4 is a point, then what is its equation? Well, we have the slope, so in order to find the solution, we need to separate the variables. So I'm going to put 1 over y dy equals 4x dx. And so see, in this one, they're actually asking you to find the curve. They're not asking you to find something about the equation of the tangent line. So that is your key, that you need to separate the variables. So the antiderivative of 1 over y is ln absolute value of y equals 2x squared plus c. And so I'm going to get the absolute value of y equals e to the 2x squared plus c, which is e to the 2x squared times e to the c. So I can say that y equals a e to the 2x squared. You don't need to write this, but remember a is equal to plus or minus e to the c in this case. And then we need to use our point. So we have 4 equals a e to the 0. In other words, a equals 4. So our final equation is y equals 4e to the 2x squared. C is our answer. The base of a solid is the region in the first quadrant bounded by this line here. I'm going to just find the x and y intercepts to easily graph this. X equals 4 and 2y equals 4, so y equals 2. So that's going to be that line there. Now it says, what is the volume of the solid if every cross-section perpendicular to the x-axis is a semicircle? So right there, that is going to be the diameter of my semicircle. And what is that diameter? Well, let me go ahead and solve. So I have 2y equals 4 minus x, y equals 4 minus x all over 2. So that is this right here. So that is our diameter right here, that 4 minus x over 2. And I'm going to purposely not simplify this, and I'll explain that in a minute. So our radius is going to be 1/2 of that. So our radius is going to be 4 minus x all over 4. And again, I'm purposely not going to simplify this to 1 minus 1/4 x, because I want to be able to factor something out. I'll show you that in a minute. Our area of this semicircle is 1/2 pi r squared. So I have pi over 2, and then I have this 4 minus x over 4 squared. And so I have pi over 2, I have the 4 minus x squared on top, and then I have this 4 squared, which is 16 on the bottom. And so you see that because I didn't multiply that out, I can actually pull that 16. So I have pi over 32 times 4 minus x, the quantity squared. Now I will go ahead and FOIL that. So I have 16 minus 8x plus x squared. The reason that's so important to factor that out is it's going to be easier to find the antiderivative in the next step where I'm finding the volume. And to find the volume, I have to add up all these areas, and I'm adding them all up from 0 to 4, right? 0 to 4 of this thing. And see how nice it is to be able to pull that pi over 32 out, and then just take the antiderivative of this 16 minus 8x plus x squared. And so when I find that antiderivative, what do I get? 16x minus 4x squared plus 1/3 x cubed from 0 to 4, pi over 32, 16 times 4 minus 4 times 4 squared, which is 16. Oh, those are going to cancel out nicely. Plus 1/3, and then 4 times 4 times 4, which again is 16 times 4, which is going to be 64. And then when we plug in the 0, that's going to be 0 minus 0 plus 0, so we're good there. So those cancel out, and we have pi over 32 times 64 over 3. So we have 2 pi over 3 as our final answer. That's going to be A. So this next problem here is telling us about bacteria. Ooh, y prime equals ky. So we know if the rate of change is proportional to the amount itself, that we must have an equation of the form y equals ae to the kt. It says the initial population is 1,500, so that is our A, 1,500 e to the kt is equal to y. And the population is quadrupled during the first 2 days. So that means at time 2, we have 4 times the initial amount, or 4 times that 1,500. When time is 2, so 1,500 e to the k times 2, our amount is 4 times that initial 1,500. So divide both sides, obviously, by the 1,500. And so we have 4 equals e to the 2k. Then we can ln both sides, so ln 4 equals ln e to the 2k, which is just 2k, so k equals 1/2 ln 4. So it asks you, by what factor will the population have increased in the first 3 days? So that's when t equals 3. So we have y equals 1,500 e to the k, 1/2 ln 4 times 3. Now, we don't have a calculator in this one, and we do need to evaluate. So here's a little trick. 1/2 ln 4 is equal to ln 4 to the 1/2 power, right? Because remember, ln x to the n is n ln x. So we're just applying that rule right there. So that is ln 2. That's going to make it much easier to plug that in as e to the ln 2 times 3. And now, let me just rewrite that 1500 e to the 3 ln 2, using that same property there. Isn't that just ln 2 cubed? So let's go ahead and do that. 1500 e to the ln 2 cubed, which is 8. So now, since we have e to the ln, those are inverses. See, they have to be like literally touching. You can't have anything multiplied by it, otherwise we can't use that rule. Obviously, we would have gotten the wrong answer. So once you isolate ln of something, then the e undoes it. And so we have 1500 times 2 cubed, which is 8. So by what factor will it have increased? By a factor of 8. So D is our answer there. So the region bounded by the x-axis and this y equals cosine x between 0 and pi over 2 is divided into two equal regions by this line x equals c. So we have this cosine graph, right? And we're saying that this line x equals c is going to split it into two equal regions, and we're actually only going to pi over 2. So we're only going up to there. So the area of both of them have to be equal. In order for that to be true, the area of this to be equal to the area of that, that means the integral from 0 to c, cosine x dx, must be equal to the area between c and that pi over 2. So that's it. The antiderivative of cosine is just sine from 0 to c, and this is also sine from c to pi over 2. We have sine c minus, what's the sine of 0? At 0, we are at the point 1, 0, so the sine is 0, minus, what's the sine of pi over 2? Up here, we are at the point 0, 1, so the sine is 1. So add the sine c over there. We have 2 sine c equals 1, so sine c equals 1/2. What is the angle for which the sine is 1/2? Well, we really need to know our 30, 60, 90, right? Because opposite the 30 is the 1/2. The angle is 30 degrees, which is pi over 6, because 180 divided by 6 is 30 degrees. So our answer is B. Now this next problem, if f is the antiderivative, so the antiderivative of tan squared x over x squared plus 1 is going to bring us back to f. Basically is what they're telling us, okay? F is the antiderivative. And they're telling us something about 1, and they want us to find something about 0. So remember, those are going to be our bounds. So from 0 to 1, that's going to evaluate to f, because the antiderivative of that is f, from 1 to 0. So we have f of 1 minus f of 0. F of 1 is 1/2. We're trying to find f of 0. What is the antiderivative of that? Well, that's a mess, but this is our calculator section. So take out your calculator. Go ahead and y1 and put this messy thing. So in order to enter this, we need to do the tangent in parentheses. So tan x, the quantity, make sure it's the quantity squared, all over, tan x, that whole thing squared, all over, and what's on the bottom? The bottom is, in parentheses, x squared plus 1. So now what we're going to do is math 9, fn int, from 0 to 1 of that function, y1. And the derivative is with respect to x. So we get 0.3446. In order to solve, we have f of 0 equals 1/2 minus that value that we got. So we have 0.5 minus that answer that we got, and we want to use that exact number. And so our answer is 0.155. B is our answer. In this problem, here's f, let g be the inverse. What is the value of g prime? So we're trying to find the derivative of the inverse. The derivative of the inverse, remember, is 1 over f prime of f inverse. Something you need to memorize. So we're trying to find f inverse of 0, its derivative. So in order to do that, we need to find f inverse of 0. What is f inverse of 0? If they give us f of x, f inverse of 0 means when y equals 0, what is x on our f function, right? So go ahead and use your calculator to figure that out. So in y1, I'm going to put that function x cubed minus 7x squared plus 25x minus 39. And then we need to graph it and find the zeros. So we just have 1 0 right there. I'm going to do second calc 0, left bound, right bound, and find that value. So it is exactly 3. That's really nice. So I'm going to just write out what I'm doing right here because I'm doing it at 0. 1 over f prime of f inverse of 0. F inverse of 0 we just found is 3. So now look, I'm going to do this entire thing on my calculator. I'm not even going to figure out the derivative because I have my calculator and I already had f in that y1. So all I'm going to do now is I'm going to do math 8, which is n deriv, because I want to find the derivative with respect to x of that y1 function evaluated at x equals 3. And boom, I get 10 as my answer. So my final answer is going to be 1/10 or C. A rectangle is to be inscribed in a semicircle of radius 8. Okay, so here's our semicircle of radius 8. So that would be 8, and that would be -8, and this right here would also be 8 because the radius is 8. So what is the equation of this? We need an equation here. You know the equation of a circle. X squared plus y squared equals r squared. You need to know that. So the equation of this top half is going to be y squared equals 64 minus x squared. Y equals, and it's only going to be the positive root because we only have the top half, 64 minus x squared. Okay, so they want us to maximize the area of this rectangle. A little bit tricky here, so we're going to just plop a rectangle inside of here, and we want to maximize this area. So basically, what is this base? Well, this point right here is x, comma, and we found our y, root 64 minus x squared, right? So that means this side length right here is x, and this side length right here is also x. So the base is 2x. And the height is our y coordinate, which is root 64 minus x squared. And so our area is 2x root 64 minus x squared. Okay, so just think about the coordinate. We have an x on this side and an x on this side, and the height is just that y value that we found. So in order to maximize the area, of course, we need to take the derivative and set it equal to 0. So I'm going to just do this one by hand because I think it's pretty easy to do. It is a product rule, so the derivative of the first times the second plus the first times the derivative of the second. And remember that this is that whole thing to the 1/2 power, so I do need a chain rule. So 1/2 64 minus x squared to the -1/2 times -2x. I have the 2 root 64 minus x squared, and then that 2 is going to cancel out with that 2, but I still have a minus 2x squared. So minus 2x squared on top over the root 64 minus x squared is on the bottom. I'm going to make one big fraction. If I put this root 64 minus x squared on the bottom, I also need to multiply through by it on the top, so I multiply by 1. So that's actually really nice because it gets rid of my root. 64 minus x squared minus 2x squared all over 64 minus x squared. So 2 times 64 is 128 minus 2x squared minus another 2x squared is minus 4x squared all over 64 minus x squared. Oops, and that whole thing was actually a root on the bottom because I was doing this minus this, so I needed the common denominator. Remember that our critical points are where it equals 0 or where it does not exist. So it equals 0 when 128 equals 4x squared. It's going to be 32 equals x squared. X equals plus or minus root 32. Of course, I can't have a negative side length, so I'm going to get rid of that. Then a prime is going to be 0 when that 64 minus x squared equals 0. In other words, when x squared equals 64, when x equals 8. This one isn't a possibility because if x was 8, then all of the rectangle would go into one of the sides, and so our area would obviously be 0 because it all went here and none of it could go into the height of this thing. So I'm crossing that one out. So our answer must be root 32, but they want us to maximize the area. So the area is 2x root 64 minus x squared. So I have 2 root 32 times root 64 minus root 32 squared is just 32. So I have 2 root 32 times root 32, which is 2 times 32, or 64. So E is my answer there. Finally, they tell us that this is differentiable. So in order for something to be differentiable, it must first be continuous. So let's make it continuous. So f continuous if the limit from the left, 1 plus 2, which is 3, equals the limit from the right. So the limit as x approaches 0 from the right is going to be the other equation, a times 0 plus b, which is just b. And of course, we need to check our f of 0. It's multiple choice, so you don't have to do that. I'm just being good on this one, so I'm using that second equation there, and I have the b. So in other words, 3 has to be equal to b for it to be continuous. Now how do I find a? Well, in order to be differentiable, f needs to be continuous, but f prime also needs to be continuous. So how do we make it continuous? We better find f prime first. It's a piecewise. Leave it as a piecewise. The derivative of this top part is e to the negative x times negative 1 plus 0. So that's for values less than 0. And the derivative of ax plus b is just a times 1 plus 0 for positive values. So let's simplify that for a second. We have negative e to the negative x for x is less than 0, and we have a for x is greater than or equal to 0. In order for f prime to be continuous, we need the limit from the left. So I'm going to use that top equation, negative e to the 0, which is negative 1, and then the limit from the right is just going to be a, and f of 0 is also going to be f prime of 0. And so I have that a equals negative 1. And so it's asking for a plus b, so negative 1 plus 3 is 2, so C is our final answer there. And that's it for this lesson. I hope this helped.